All right, welcome back. Today, we are diving into what I think is one of the coolest, most fascinating corners of AI. We're talking about reinforcement learning.
So imagine this for a second. An AI, it just sits down and teaches itself how to play dozens of old school Atari games. I'm talking Space Invaders, Pong, the whole lot. And it doesn't just learn to play, it gets so good it's better than any human on the planet.
But here's the absolute mind bender. Nobody ever taught it the rules. Think about that. It had no idea what a paddle was, or that you're supposed to shoot the aliens, or that, ghosts are the bad guys. It just figured it out. So the big question is, how on earth is that even possible? Okay, let's pull back the curtain. The secret, and this is the beautiful part, is incredibly simple. It's all about trial and error. And that right there, that's the heart of reinforcement learning. It's this whole area of machine learning where an agent, that's just our AI or learner, figures out what to do by just doing stuff and seeing what happens. There's no teacher telling it good job or that's wrong. No answer key. It's just learning purely from the consequences of its own actions. The whole thing runs on this really simple but super powerful loop. So step one, the agent, our little AI player, looks at the environment. In the case of Atari, that's literally just the pixels on the screen. Then, step two, it takes an action. Maybe it moves the joystick left. Then, step three, the environment gives it some feedback, a reward or maybe a penalty. Did the score go up? Awesome. Did it die? Not so awesome. And then, step four, it just does this again and again and again, millions and millions of times until it's a total pro. So, you might be asking, what's actually driving all this learning? What's the motivation? Well, it all comes down to one simple, powerful idea, the reward.
And this idea is so fundamental, there's a name for it in the field. It's called the reward hypothesis. And it's a really bold claim. It basically says that any goal you can think of, I mean anything, from winning a game of chess to, flying a helicopter, can be boiled down to one simple objective, getting the highest possible score over time.
Let's make this real. How does it work in practice? Well, if you want to teach a robot to walk, you could just give it a +1 reward for every step it takes forward, and maybe a big fat -100 penalty if it falls over. Simple. If you're building an investing bot, the reward is just the money it makes or loses. And for our Atari player, it was even simpler. The reward was just the points on the screen. You see the pattern? You take a really complex goal and turn it into a single number that the AI just has to make as big as possible. Okay, so we get what it's trying to do. Rack up that sweet, sweet reward. But how does it actually decide what to do in any given moment? What's going on inside its brain? Let's crack it open and take a look. So the first big piece of the puzzle is something called the policy. The easiest way to think about this is that it's the agent's strategy. It answers the question, what should I do right now? So if you're in a maze, the policy is like having a little arrow painted on the floor of every single square telling you exactly which way to turn. No thinking, just doing. But that's not the whole story. The second piece is the value function. And this is different. It's not about what action to take, it's about judging how good your current situation is. It tries to predict how much reward you're going to get in the future from this point on. So back in our maze, the value function isn't an arrow. It's a number written in each square that tells you how close you are to the final treasure. A high number means you're doing great. A low number, not so much. So let's just make sure that's crystal clear. The policy is the strategy. It's the what to do. The value function is the judgment. It's the how good is this. And to be really smart, an agent needs both, right? The policy tells you the move, but the value function tells you whether that move is part of a winning long-term plan. That's how it learns to think ahead, not just one move at a time. Now, learning this way, it creates this fundamental problem. It's a challenge that, honestly, you and I deal with every single day. And it's called the explorer's dilemma. It all comes down to this constant trade-off between exploration and exploitation. Let's use an example we can all relate to. Picking a place for dinner. Exploitation is when you go to your favorite restaurant. You know the food is good, it's a safe bet, you'll be happy. Exploration is when you try that brand new place that just opened up. It could be the best meal of your life, or it could be a total disaster. An RL agent is always facing this choice. Should I stick with what I know works, exploit, or should I try something new that might be even better, explore?
And look, this whole idea of balancing risk and reward, it goes way, way beyond just playing video games. Let's zoom out now and see how this one simple concept is literally changing the world.
At this point, a lot of experts see reinforcement learning as something huge, not just a programming trick, but the fundamental science of making the best possible decisions. It's a blueprint for solving any problem where you need to learn how to reach a goal in a world that's messy and uncertain.
And because it's such a powerful idea, it's already being used, well, everywhere. It's in robotics, training robots to walk and grab things with a level of skill we just couldn't program by hand. It's in finance, powering trading algorithms that make decisions in microseconds, way faster than any human could. It's being used to manage incredibly complex things like entire power grids. And get this, it's even helping neuroscientists understand how our own brains learn. Because it turns out this is a lot like how our dopamine reward system works. So there you have it. From mastering Pong to managing a power grid, reinforcement learning is this incredible way to get machines to teach themselves how to solve incredibly hard problems. Which brings us to one final, really big question for you to think about. If you had a machine that could learn to do pretty much anything just by trying things out, what problem would you ask it to solve?